In this video, you will learn comparison between working stress method and limit state method. The comparison will be made on the basis of stress strain curve, design load and possibility of overloading, ease in calculation and application to complex structures, calculation of moment of resistance from tension and compression side, moment of resistance of balance section and economy. So let us understand the comparison of working stress method and limit state method based on these criteria. So welcome back to one more video on design of reinforced concrete structures using working stress method and limit state method. Before we start actual comparison between these methods, let us first understand what are the methods and design philosophies available for design of RCC structures. There are two types of methods used for design of RCC structure: experimental method and analytical methods. Now let us first understand where this experimental method is adopted. Now whenever new material is developed, they are tested and used on the experimental basis. Once they have been found suitable, theoretical methods are developed. Experimental methods can also be used when structure is very complicated. In this, model studies are carried out first and then prototypes are built. These experimental methods are very time consuming and cannot be accepted for design of each and every structure. Now these analytical methods are based on identifying failure criteria based on material properties. There are three design philosophies used in design of RCC structures, that is working stress method, ultimate load method, which is also called as load factor method, and limit state method. Working stress method is the first method which is developed to design the RCC structure in the year 1900. After that, ultimate load method is developed in the year 1957, and then limit state method is developed in 1964. Now in our IS code, this limit state method is accepted in 1964, but this method was not made compulsory in earlier code. Now in IS 456-2000, limit state method is made mandatory. Now it is compulsory to use limit state method only. Now since there were some drawbacks of first two methods, that is working stress method was giving uneconomical design and thus design made by second method, that is ultimate load method, was not serviceable. That means there were large deflections and vibrations in the structures, and therefore the third method is developed, which is limit state method. This method avoids the drawbacks of working stress method and ultimate load method. Working stress method and limit state method, these are the two methods commonly used for design of RCC structure, and therefore now we will compare these two methods on the basis of stress strain curve, design load and possibility of overloading, ease in calculation and application to complex structures, calculation of moment of resistance from tension as well as compression side, moment of resistance of balanced section, and economy. So let us start. Now first we will compare the working stress method and limit state method on the basis of stress strain curve for concrete. Now if you plot a stress strain curve for concrete, in working stress method there is linear variation. Because working stress method is based on elastic theory, and it is assumed that the concrete will act elastically and follow the Hooke's law. That means stress is proportional to strain, and therefore there is linear stress strain curve adopted in working stress method. Whereas in limit state method, if you observe your IS code IS 456-2000 on page number 69, this curve, stress strain curve for concrete is given. Now in this curve, it takes into account the non-linear elastoplastic stress strain behavior of concrete. Now in initial stage, the concrete is in elastic stage, so it is a curved portion, and after that the concrete behaves like a plastic, and therefore there is horizontal portion in this graph. This behavior is called as elastoplastic behavior of the material. So limit state method takes into account non-linear elastoplastic behavior of the material. So the curve in working stress method is a linear curve. It is a straight line. Stress is directly proportional to strain, and it follows Hooke's law. Whereas in limit state method, there is elastoplastic behavior of the material. So this is the comparison of stress strain curve for concrete. Now let us understand how will be the stress variation in the concrete of the beam if we adopt linear stress strain curve as in working stress method. Let us consider this beam, RCC beam. If the load is applied to this RCC beam, the top portion above the neutral axis is subjected to compression and bottom portion is subjected to tension. In RCC design, our assumption is we neglect the concrete in tension zone, and therefore in RCC beam we consider only this part as a concrete part. Now how will be the variation of the stress if the stress strain curve is linear? So in working stress method, the stress variation is linear like this because of the assumption of stress is directly proportional to strain. Now we will see how it will be in limit state method. As we have seen, in working stress method, the concrete is assumed to act elastically, and therefore the stress variation in concrete is linear. Now in limit state method, the stress strain variation is assumed as non-linear elastoplastic. So how will be the stress variation in case of limit state method? So if you refer your IS code page number 69, the curve is given on page number 69 of IS 456. So it look like this. So top portion is rectangular, whereas bottom portion is non-linear. So top portion, in this case, this is the elastoplastic behavior of the concrete. The top portion, which is near the extreme fibers, is under plastic stage. So these fibers are in plastic stage, whereas the fibers which are near the neutral axis are under elastic stage. So there is non-linear variation. Remember that here the line is not a straight line. It is not a linear variation. It is non-linear variation. So such type of variation is called as elastoplastic behavior of concrete. So in limit state method, it takes into account non-linear elastoplastic stress strain behavior of concrete. Now let us see the stress strain curve for steel. In working stress method, if you plot stress versus strain, then in working stress method, the steel is assumed to act elastically and it follows Hooke's law. That means stress is directly proportional to strain and therefore this stress strain curve is a linear curve. So there is linear variation in case of working stress method. Now in limit state method, if you refer page number 70 of your IS 456, you can see the stress strain curve for steel. So in this curve, the initial portion of the curve is in elastic stage, whereas the horizontal portion represent the plastic stage. So here in limit state method, it takes into account the elastoplastic stress strain behavior of steel. Now the next criteria for comparison is design load and possibility of overloading the structure. In working stress method, the stresses in the structural member are considered for normal working load without considering the condition existing at the time of failure. Whereas in limit state method, the design is based on ultimate load. Ultimate load is also called as factored load at the time of failure. So this ultimate load is calculated by multiplying the working load by partial safety factor. That means whatever the load we consider in working stress method, that is to be multiplied by partial safety factor for load to get the ultimate load. So in working stress method, the design is based on normal working load, whereas in limit state method, the design is based on ultimate load. In working stress method, since we design the structure on the basis of working load, it does not give any idea about the excess load the structure can carry without collapse. Whereas in limit state method, it gives an idea about the excess load which a structure can carry beyond the working load without collapse. For example, if you are designing your structure for dead load and live load, we multiply the working load by 1.5 to get the ultimate load. That means 50% excess load the structure can carry beyond the working load without collapse. So it can take 50% excess load because we are multiplying the working load by 1.5, that is partial safety factor for load to get the ultimate load. Therefore, there is possibility to put the excess load beyond the working load. So we have idea about the excess load which a structure can carry beyond the working load without collapse in case of limit state method. Next point of comparison is ease in calculation and application to complex structures. As you know that working stress method is based on elastic theory, it is a simple method and due to simplicity it is used for design of complex structures. Whereas limit state method, it is somewhat complicated method which involves more calculation than working stress method. So this is normally used for design of all the regular structures. For design of complex structures, this method is still developing. Now limit state method is now adopted by our IS code for all type of structures. Since when we design our structure using limit state method, it satisfies the collapse condition as well as serviceability condition. So the structure which is designed by limit state method is economical as well as serviceable. Next point of comparison is the procedure for calculation of moment of resistance using working stress method and limit state method. But before we start studying the procedure for calculation of moment of resistance, first of all, let us understand what is meant by moment of resistance. So for that we will consider a reinforced concrete beam of size B by D as shown in figure. So if it is a simply supported beam and if it is loaded, the top portion above the neutral axis will be subjected to compressive force, whereas bottom portion will be subjected to tensile forces. So as you know that in RCC beam, the concrete below the neutral axis is neglected and we assume that tensile forces are carried by reinforcement only. So therefore the tensile forces will be developed at the point of reinforcement. So this, for equilibrium, this total compressive forces is equal to total tensile forces. So C is equal to T. Z is the distance between these two parallel forces. So C and T are equal and opposite and they are parallel, so they forms couple. So moment of this couple is nothing but moment of resistance, and we know that moment of couple means either we can calculate C into Z or T into Z. So this is how we calculate moment of resistance. So let us see what is the definition of moment of resistance. So moment of resistance of reinforced concrete section is equal to the moment of couple formed by the total tensile force T in steel acting at CG of reinforcement and the total compressive force C acting at CG of compressive stress diagram. So this is the definition of moment of resistance. Now we will see how we can calculate moment of resistance from compression side and tension side using working stress method and limit state method. The second term which we use in calculation of moment of resistance is lever arm, which is denoted by Z. So for stability, the total compression developed in concrete is equal to the internal tension developed in steel, that is C equal to T. As I told you that this forms a couple which resists external bending moment due to load, and therefore while designing the structure we always equate moment of resistance to external bending moment due to load. Now the arm of this resisting couple is called as lever arm. Now we will compare the procedure to calculate moment of resistance using working stress method and limit state method. First of all, we will see how to calculate moment of resistance from tension side. As you know that in working stress method, the variation of stress diagram is linear like this. It is maximum at the extreme fiber and it is 0 at the neutral axis. Now here the depth of the neutral axis is XA, so total compressive force will be developed at the CG of this triangle. So if XA is up to the distance up to the neutral axis, then this C total compressive force will act at CG of this triangle, which is XA by 3. Then at the point of reinforcement, the total tensile force will act. So the distance between C and T is called as Z, which is nothing but lever arm. So total height is D, total effective depth is D. So distance between C and T will be equal to D minus XA by 3. So what is moment of resistance? Moment of resistance is nothing but the force forming the couple multiplied by lever arm. So moment of resistance from tension side in case of working stress method is calculated from this diagram. So moment of resistance is equal to T into Z. Now what is T? T is tensile force. We know that formula, stress is equal to force upon area, or force is equal to stress into area. So here in this formula, T is tensile force in the reinforcement, which is equal to permissible stress in the reinforcement multiplied by area of the reinforcement. So we will substitute T, and Z is D minus XA. So we get moment of resistance. So this is T, which is nothing but the area into stress, which is equal to force, multiplied by the lever arm D minus XA by 3. So this is how we calculate moment of resistance using working stress method from tension side. Now we will see how to calculate moment of resistance using limit state method from tension side. To understand the calculation of moment of resistance using limit state method from tension side, first of all we will draw the stress variation diagram like this. So here C is total compressive force developed in the concrete and T is the total tensile force developed in steel. C act at 0.42 XU from the extreme fiber. This is given in your IS code. So therefore Z, which is a lever arm, is nothing but D minus 0.42 XU. So therefore the moment of resistance from tension side is T into Z. So T is the force, which is stress into area multiplied by Z. So the formula will become like this. Moment of resistance is equal to stress into area is the force T, and D minus 0.42 XU is the lever arm. So remember that if you compare these two formula, in first formula, in WSM formula there is sigma ST, whereas in LSM formula there is 0.87 Fy. So sigma ST we can get from IS code. There is one table given in the IS code to get the permissible stresses in steel in working stress method. So from there we can take the value of sigma ST. Whereas in limit state method, Fy depends on grade of steel. If it is Fe 250 grade of steel, then Fy is 250. So just by multiplying it by load factor 0.87, so 0.87 Fy is the permissible stress in limit state method. Multiplied by area, we get the force in the reinforcing bar. Multiplied by Z is the moment of resistance. Normally in limit state method, moment of resistance is denoted by Mu, that is ultimate moment of resistance. So this is from tension side. Now we will understand the moment of resistance from compression side. To calculate the moment of resistance from compression side using working stress method, we have to consider this stress diagram. So here the stress in concrete is a linear variation like this. Sigma CBC means sigma means stress in concrete in bending compression. Sigma CBC is the stress at the extreme fiber, and at the neutral axis stress is 0. So average stress is 0 plus sigma CBC divided by 2. So in this case, to calculate the moment of resistance from compression side, we have to take the moment of compressive force C. So C into Z is nothing but the moment of resistance from compression side. Now as you know that C is a force and force is stress into area. So this we can write like this: moment of resistance is equal to stress is average stress, which is sigma CBC by 2, and area, which area is resisting compression? it is B into XA, which is shown with green color here. So this area is resisting the compression. So B into XA is the area, and stress, since it is varying from sigma CBC to 0, we have to take average stress. So 0 plus sigma CBC by 2, we get sigma CBC by 2. So what is this? This is nothing but the compressive force developed in concrete. So it is area multiplied by average stress. And we know that Z, which is lever arm, is D minus XA by 3. So this is the formula to calculate moment of resistance using working stress method. Now we will see same, that is moment of resistance from compression side using limit state method. To calculate the moment of resistance using limit state method, we have to first draw the stress diagram like this. So here the moment of resistance is nothing but C into Z. Now value of C is average stress in this block is 0.36 FCK. Now which area is resisting compression? It is B into XU. So B into XU is nothing but the area, and this is the stress. So stress into area is nothing but force C, and Z is the distance between C and T, and it is D minus 0.42 XU. So if you compare the formula in working stress method and limit state method, you can observe that in working stress method there is sigma CBC. Sigma CBC means permissible stress in concrete in bending compression. This value is available in IS code, whereas in LSM we directly use FCK. FCK means this we can read from grade of concrete. For example, if grade of concrete is M25, then FCK will be 25. So this is how we calculate the moment of resistance from compression side using working stress method and limit state method. Next point of comparison is moment of resistance of balance section. We need this moment of resistance of balance section while designing the section. While designing RCC section, we equate moment of resistance to external bending moment due to load. So to decide the size of the section, we have to calculate the moment of resistance. So in working stress method, moment of resistance is calculated using this formula MR is equal to QBD square. So in this we equate moment of resistance to bending moment and we decide the depth of the section. In limit state method, the formula is KFCK BD square. Now if you compare both the formula, in both the formula there is BD square, where in working stress method there is Q, whereas in limit state method there is K into FCK. Now what is this Q? Q is half sigma CBC into K into J. So here sigma CBC is included in the formula of Q, whereas in this formula FCK is separately given. Now in this formula there are again two coefficients K and J. K is called as neutral axis depth factor, whereas J is called as lever arm factor. Now how we calculate this? So J is equal to 1 minus K by 3, where K is neutral axis depth factor. Now K we calculate using M upon M plus R, where M is 280 upon 3 sigma CBC. This formula is available in IS code. And R is ratio of permissible stress in steel to permissible stress in concrete in bending compression. So using this formula we can first calculate Q, substitute here, equate moment of resistance to bending moment, and we decide the size of the section. So this is moment of resistance of balance section in working stress method. In limit state method, this moment of resistance is K FCK BD square. Now here K we calculate using this formula. So this factor is also you can read from IS code. XU max by D, in this formula there is XU max by D. This is obtained from this formula 700 divided by 1100 plus 0.87 Fy. Fy we get from grade of steel. Now here this formula XU by D is equal to 700 divided by 1100 plus 0.87 Fy. This formula is actually not available in IS code, but this we can derive from strain diagram. So I will provide the video on derivation of this formula for XU max by D, which is used in calculation of moment of resistance using limit state method. Now this is the comparison of moment of resistance of balance section using working stress method and limit state method. Now in limit state method, you can see here there is Fy. In this formula only Fy is unknown. So if you know the grade of steel, for example if it is Fe250, then Fy is 250, Fe415, then Fy is 415. If you substitute this, you can get the value of XU max by D. That value you have to substitute in the formula of K and you have to obtain the value of K. So for simplicity we can remember this value of K. So if you substitute value of 250, 415 or 500 in this formula, we can get the value of XU max by D like this 0.53, 0.48 and 0.46, and therefore K value is 0.149 for Fe250 steel, 0.138 for 415 steel and 0.133 for Fe500 steel. So you can remember these values and you can directly use these values while designing the section. So these are the values of K. You can directly substitute these values in this formula for limit state method. So if you substitute this value, this formula will look like this for Fe250 steel. While designing any element using Fe250 steel, you can directly use this formula 0.149 FCK BD square, equate it to moment of resistance. This is the moment of resistance. Equate it to bending moment and get the value of the dimension of that beam. If it is Fe415, you can remember this 0.138. So you don't have to calculate it. You just remembered 0.149, 0.138 and 0.133 for Fe500. So this is how we calculate moment of resistance of balance section using working stress method and limit state method. Next point of comparison is economy. Now as you know that working stress method is based on only elastic behavior of the material. Therefore material strength is not fully utilized and there is large factor of safety involved in working stress method design. Therefore it gives uneconomical section. Whereas the limit state method is based on elastoplastic behavior of the material. So material strength is fully utilized and therefore it gives economical design. So design by limit state method is economical as well as serviceable, and therefore limit state method is preferred. This is how we compare working stress method and limit state method on the basis of various criteria. This is all for today. Let us meet in next video. Thank you.